Hello everyone, my name is Harnit Saini. I am assistant professor in Ajay Kumar Garg Engineering College. Today the topic of my discussion is normal forms, which is a topic in fourth unit of DSTL. First, the definition of a normal form. A Boolean function of n variables is said to be in normal form if it contains all the n variables. For example, let's suppose there are two variables x and y. Then the normal it will be in the normal form when there are various combinations of x and y in that, like x plus y bar, x plus y bar, etc. Right? Now basically there are two types of normal forms, DNF and CNF. DNF is disjunctive normal form and CNF is conjunctive normal form. Before we start the further, we should know what are min terms and max terms. Min term is the product term, right, in which all the variables are multiplied by each other. Like min term is the product term or complete product of n variables and is denoted by small mg, right? For example, the min terms generated by three variables x, y and z are all the product terms like x, y, z, x, y dash z, x dash y, z, etc. And what is a max term? Max term is the sum term or complete sum of n variables denoted by capital Mj, right? For example, the max terms generated by x, y, z are x plus, here the variables are added to each other. In min terms, they are multiplied by each other, right? This is the difference. Now, let us suppose we are given with this data, right? We have three variables x, y and z, right? And these are the possible values which can happen in a problem, right? Now, first of all, for this, if we are to calculate what is the min term, then we will see where it is 0, we will put a bar. See, for the x value we are having 0, so we will put x bar here. For y value we are having 0 again, we will put y bar, and z value we are having 0, we will put z bar, and we will multiply all these because min terms are always multiplied. Okay. Now let's check the another value. Here x is 0, y is 0, so x and y bar, and z is 1, so we will write z as such like this. And in this 0, 1, 0 means x is 0, then for x we will put a bar, 1 for y, so y will be like that only, 0 for z, so 0 bar. This way we will calculate all these min terms. Now, the max terms are the complement of the min terms, right? If we take the complement of this, we will get the max term, right? So, if we are want to calculate the max term directly, so what we will do, instead of 0, we will not put bar here now. For 0, we will consider it as a 1 in min term. What we do for 1 in min terms, we will do for 0 in the max terms, right? Now see here, we are having 0 here, we will put x here. We are having 0 for y, we will put y here. We will having 0 for z, we have put z here. Now the max terms are always added to each other, right? And min terms are multiplied to each other, and max terms, in this the variables are added to each other. Similarly, the next part, here we are having 0, so we will have x, 0, then y. Now here we are having 1, then we will put a bar in there, right? There the functions are reversed here now, and fair product will be converted to sum, right? So these all are the min terms and they are denoted by small m. So m0 means is the 0th position, this is the min term here, right? And third we have this, for 7th we have this. Similarly, for max terms, we denote these by capital M, right? And this shows 0, so this is the first term here, and this is the second term, third, and so on, right? Now, we will see what is a DNF now. When a Boolean function is expressed as sum of min terms, see, If we sum all these terms, we will put a plus sign in this, then it means it is a DNF, disjunctive normal form, right? All the min-term expansion of the Boolean function canonical form, it is also referred to as sum of products or SOP, means sum of products here. Now you can see the example here. Here these are min-terms because their variables are multiplied to each other. And then we are summing these products. So that means it is a sum of products. Similarly, for three variables, you can see here we are having three products, first, second and third. That means there are three min terms, and when we add to each other, then it is converted to DNF, right? Now this CNF is reversed of that and DNF. Now here we will take the max terms, and max terms are added to each other, and when we take the product of these all max terms, then we get the CNF, conjunctive normal form, right? Let's read the definition. When a Boolean function is expressed as a product of max terms, then it is called a conjunctive normal form or max term expansion of Boolean function. It is also referred to as product of sums form. It is called POS. There we were paying SOP, and this is POS. Now see here how many this is the first max term, this is also a max term, right? When we take the product of it, we get a POS, that is conjunctive normal form, right? Similarly, you can see for three variables, here these are the max terms, we are taking the product of this, then it is converted to conjunctive normal form. Now to convert a given equation into a DNF, there are some rules how to convert it. So let's study the rules, then we will solve some examples to understand it better. First is write the Boolean expression as a sum of products by using Boolean identities. Because DNF is the sum of products, we have to convert it into the given equation into sum of products, right? And then in some of the min terms, maybe one or two variables are missing. Like suppose if we are writing x plus x y bar, right? For first term, it is a equation in two variables. In the first term, y is missing. Here it is okay, right? Now the y is missing. So what we will do is multiply those Boolean expression by as many 1 as the number of missing variables. So what we will do, we will multiply it by 1. The equation will not change because anything multiplied by 1 gives the answer same, right? We will multiply this with 1. Replace 1 by sum of the variables and its complement. Now 1 can be written as y plus y bar, right? Because here for this term y is missing, right? So we will write here x into 1, and in case of 1 we will substitute y plus y dash, right? Then apply the distributive law. Then for this term we will apply the distributive law, right? Then this term can be written as x into y plus x y dash. So the equation we achieve after that is, this will be written as xy plus xy dash, and this term will be added. So this is our final thing. Now we can see that these two terms are repeated here. So there is no need to repeat the terms, no? So we will take only these two terms, xy plus xy dash. So what this is the required DNF, right? Now go through the rules again. So what is happening? First of all, we have to convert this equation into sum of products, right? If it is in CNF, we will convert it into DNF, right? By applying the distributive laws. Then when we will check how many variables are missing here in each term, right? In each min term, how many variables are missing there? So if suppose there are 3 variables and 2 variables are missing in the one min term, then we will multiply it 1 by 2 times, one with the first missing variable and second one will take the second missing variable, right? then 1 will be converted into the sum of that particular variable and its complement, right. Then we will open the bracket with the distributive law, and then we will cancel the repeating terms. The ultimately left out terms will be our required DNF, right. Now let's take one example. This is the Boolean function x plus y bar z. Now we know that we are having three variables, right. For the first term x, y is also missing and z is also missing. So x will be converted into x into y plus, first we will take the first variable, x into y plus y bar, means y plus y bar is always 1, right. 1 into x will be x only. Now we will apply the distributive law and we will get this, right. Now we will take, now these two terms are we have achieved, but z is again missing in both of them. So what we will do, here also we will multiply it with z, and here also we will multiply it with z, right. Now see here, we will apply again the distributive law and we get this. Now x is converted, this x is converted to this DNF, right. Now we can see in the second variable x is missing. Now the second term, this one term is missing, that is x, right. So we will multiply it. So we will multiply it with x plus x bar here, because that is again 1, and we will open the brackets, apply the distributive law, and we will get these two terms. Now what is the required function is this what we achieved from the first term, and this is our second term. We will combine these both, okay, f x y z. Now we can see what are the repeated terms here, x y z, no, x y z is written here, then x y z bar, this is also okay, and then x y bar z, x y bar z. See, these terms are repeated here. So we will not write it two times, we will cancel one and take it 1. Then x y bar z bar, okay, x bar y bar z, okay. Now this is our required DNF. Now how we will check it? See, all the min terms which we have got, they have x, y and z, all the three variables in that, okay. Now we can solve this same example with the help of truth table also. Now see, these are the three variables x, y and z, right. These are the possible combinations which we can have it. Then what is the what all we are required? The first we require is x. So x we already have here. Then we require y bar. So we have converted y into y bar here. We have taken the complement of y here, right. Then y bar z, right. Y bar z we have calculated here. We are multiplying this one and this one, right. 0 and 1 0, 1 and 1 1, 0 and 0 0. This way we can calculate the whole column. Now we will calculate the f x y and z, right. We will add these terms, this one and this one, x and this we will add, we will get this output, right. See, 0 and 0 we will get 0, 0 plus 1 we will get 1, 0 plus 0 we will get 0, right. This way we will calculate the whole column like this. Now we know that the min, this is we know that these are min terms because they are multiplied to each other. So min terms are where the output is 1, right. Now we can find out that 1 is here and here. So we will see what are the values here. For 1, what is x? 0, y is also 0 and z is 1, right. So x bar, y bar and z, right. So and for 1, for this, x, y bar, z bar, x, y bar, z, x, y, z bar, x, y and z. These are the min terms we achieved here. So, okay, and you can see that we are getting the same answer which we got here, and through the truth table also we got the same answer. So you can do any of the method to solve this type of questions. Now we are to convert to CNF, means we have to now find the max terms, right? Now write the Boolean expression as the product of sums. There we were doing sum of products, here we will write product of sums, right? And add those terms of Boolean expression by as many zeros. Now anything added to 0 will give the same thing again, right? So whatever is the term is missing there, we will replace the 0 by that, right? Now so what we were doing, we were multiplying it with 1. Here we are taking the product of sums. So sum, we have to create one more sum, so that means the number which is missing, the variable which is missing, that we will replace it by 0. First we will take it 0, then put that variable on the place of 0, which we did in place of 1 in case of SOAP, right? Means disjunctive normal form. Now replace 0 by product of variable and its complement. Now see here, 0 can be written as x into x bar, right? So we can replace 0 with the variable which is missing, right? And apply the distributive law, again the same method which we did in the first one, and then the terms which are repeated we will cancel that, and the left out terms will be CNF, right? Now see here, this is the Boolean function AB plus A bar C. Now we can see that this is not a CNF, right? This is DNF. First step was we have to convert it into CNF. So what we will do, we will apply the distributive law. In Boolean algebra, addition is also having a distributive property. So we will open this A plus A bar this way, then A bar plus B this way, A plus C and B plus C, right? Now we got this one. This is now CNF. We have converted it to CNF because we are having now max terms. So A plus A bar is always 1. So we will cancel it. We are left with these terms, right? So we will write this. Now we will see which are the terms missing in that. Now we will take the first one, right? A bar B. We are not having C here. So we have to insert C in this. So what we will do is, we will write A bar plus B is equal to, we will do it plus 0, okay? And in place of 0, we will write CC bar, right? Open the brackets again with the distributive law, and after this we get A bar B plus C and A bar B plus C bar, right? Similarly for the second term now. For A plus C, B is missing now, right? Then we will write B bar here. Again distributive law we will apply and open the brackets. For B plus C, we see here A is missing. So we will write A bar in place of 0 and we will open the brackets now. Now all the 3 terms are expanded now. We will add, we will all join all these, means we will multiply all these because this is a CNF, right? So when we multiplied all these terms, we will cancel the repeated terms. First we will check of A bar B C. A bar B C is also here also. So we will cancel it and take it once. We will take this. Then A bar B C bar. It's not there. We will take it. A plus B plus C. See here, and these are repeated here. We will leave 1 and take it 1. Then A plus B bar plus C. Right. So this is the required CNF which is left out. Now let's solve it with the help of truth table now. These are the variables A, B, C, right? 3 variables are there. These are the possible combinations. The first term is AB, so we will calculate AB here. The second term is A bar C. So first we will calculate A bar and then we will calculate A bar C, right? So we will form the truth table like this. Now we have to write here F A, B, C, there's AB plus A bar C. So we will add this term and this term. We will get this output, right? Now what we have to do is, because we know that we have to convert it into CNF, this term is, this is the CNF, so we will find out the zeros now. In DNF we will find out the 1 and in CNF we will find out the zeros. So we found zeros here, here and here, right? So now in case of when we find zeros, the method is reversed to DNF. So for 0 we will take A now, see here, A is 0, we will not take A bar, we will take A, and for 0 B we will take B, and for C0 we will take C. We will not put bars here, it is reversed now, and there we were multiplying, now we are adding this to create a max term, right? Again, for this 0 we got this 0 we got this 0 we got this, right? We have found out all the max terms here. So you can see here the answer we make, which we got here, with that also truth table also we got the same answers. Okay. Now if there we have got, first examples were, they were mixed equations, right? Now there is a proper DNF, we have to convert it into CNF. Now what is the example? What is the method here now? Determine F bar by finding the sum of those terms of complete DNF in F which are not present in the given F function. Okay, now you can see that if we are having 3 variables, so that means we are having 8 combinations. 2 raised to power 3 is 8, we are having 8 combinations now. Now whatever the question is given, whatever the equation is given, we will find out that what term is missing from the 8 terms in that particular expression, right? And that we will denote by F bar. Now F will contain 5 terms, 6 terms, 7 terms, or any terms, right, out of those 8 terms. So we will find out which terms are missing, and that we will denote by F bar. Okay, then what we got in F bar, we will take the complement of this, because we have to convert DNF to CNF. CNF is always the complement of DNF, right? The left out terms we will take the complement. Complement of complement, again we get the expression, right? So we will solve it and we will apply the De Morgan's law to solve it, and we will get the expression, right? Now let's take an example. This is the DNF, this xy, see xy, xy dash and x dash y dash. Now all the 3 terms which are in this, all the 3 are having both the variables, x also and y also, but it is in the DNF form. Now we have to convert it into CNF form. Now we will see here xy, xy dash, x bar, y bar. Now when we are having 2 variables, we are having 4 combinations. 2 raised to power 2 is 4, so 4 combinations are possible here. So 3 are given, only 1 is left. What is that left one? The complete DNF is this, 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 and this is left out, right? We will take this as F bar, right? We will write it, F bar xy is x bar y, which is the left out one, we will donate it with F bar, right? Means F complement. Now we will take the complement of this. When we take the complement of this, we get x plus y bar, right? So this is the required CNF now, right? Again, I will tell you what is happening here. So you see again, we are having 2 variables, right? Each and every term is made of 2 variables only. That means it is a complete DNF. Now we have to convert it into CNF, right? Means out of these 3 out of 4 combinations which may be possible, because there are 2 variables, there are 4 possibilities are there, 4 combinations, and we have got 3 only. So that means 1 is missing. We have to find that which one is missing. We got that x bar y is missing here. We will donate this missing one as F bar, right? and we will take a double complement. We will take the complement of this and we will get this, right? That is the CNF. Now CNF, we are having two variables and it is in the form of max term, right? Now same question we can solve with the truth table also. See here, this is x, this is y, these are the possible combinations of this. Now we all know this is a DNF, so these are the min terms here. We will write down the min terms. The left out term will be denoted by 0 here, because we don't know what is the term there, right? We will write 0 here only in place of that, right? Rest all are 1 because these are the min terms. Min terms we look the output 1. So that means if these are min terms, the output is 1 and others are 0. We will put 0 here. Now we have to calculate the max term here. We will see what is the max term here. X, below x we are having 0. So that means x is not barred here. X we will take as such. Y is 1, that means y bar here. Y, x plus y bar. So we got the same answer which we got in that. So that means we can solve this question also with the truth table. Now we can we will discuss the example with the three variables. So see this DNF now. All the terms 1, 2, 3, 4 and 5, right? All the terms are having all the three variables. That is the complete DNF now. Now we have to convert it into CNF. As you see, there are 5 terms with 3 variables. 2 raised to power 3 is 8. So there are 8 possibilities, but they are given only 5. That means 3 are left out. Now we have to find out which 3 are left out there, right? Complete DNF is this one. These are all the 8 terms, right? What are left? X, Y, Z bar. X, Y, Z bar is not present here. X bar, Y, Z. X bar, Y, Z is also not present here. X bar, Y bar, Z is also not present here. So we have find out this these terms are missing from the given expression and we will denote it by f bar x, right? Now we will find out the complement of this, right? We will find out the complement. This will be converted to x bar, y bar, z, x plus y bar plus z bar, this one, x plus y plus z bar, this, right? Now this whole term is the required CNF. Now you can see the answer we have got. It have all the 3 variables in that and all are added. They all are max term. So it is a complete CNF now, right? Now let's solve it with the help of truth table. See here, this is the question which is given to us, which is the expression x, y, z, right? And this you can see that all the terms I have marked here. All these are the min terms. So wherever the min terms are marked, see here x bar, y bar, z bar, x bar, y and z bar. This way you can mark it, right? Now the left out terms, min terms are always 1, output is always 1. So we have inserted 1 here, right? So left out will be all zeros. So these are all zeros. So for max terms we have to look for zeros. So first 0 we got here. Here x is 0, y is 0 and z is 1. Now the functions are reversed. So we will get here x, y and z bar. And we will add all these terms because it is a max term. Now here 0, here we got x, y bar, z bar, right? X, y bar, z bar, and we will add it because these are max terms. Similarly for this 0, x bar, y bar and z, x bar, y bar, z, right? Now these are the required max terms of this, and for CNF we will find out the product of sums, right? So this way we got again the same answer which we got in the previous one, right? Now we will convert a CNF to DNF, right? Now the methodology will be same, but the functions will be reversed now. Now we will find out again f bar. How we will find out? We will find out the missing terms in that. which are not, we have all the combinations, and we will check the expression which all terms are missing there. We will assign it to f bar and then take the complement of that, and we will get the required DNF. Right? This is the same procedure, but in that there were min terms, and now in this we will have max terms. Right? Determine the complement f. First we will find out f dash, then we will find the complement of f dash, which will be f double dash, which is again f, right? And then we will simplify it and we will get the required DNF. Let's take an example. First we will do in two variables. So these you can see here, these are the max terms, and all are having the two variables in this and all are in the this pause form, right? Now we will see what is, these are three terms, and for two variables we should have four terms. So we have to find out the one term which is missing in this. See here, which one, this is the term which we are given, and these are the possibilities that can happen. So out of these four, these three are gone, and this one x bar y bar is not present in these three terms. So we will take it as f bar, right? We will find the complement of this and we get xy. This is the required DNF. Now let's see with the help of this your truth table, xy possible combinations. Now we will mark this x plus y. Now we have to see x plus y, means x is written, that means x should be 0. So x is 0 and y should be 0, right? X plus y bar means x should be 0 and y should be 1, 0 and 1. X bar plus y, x should be 1, y should be 0. So this is the combination, and the left out will be 1. Now you see, these are the max terms. The output for the max terms are always 0. So we will put 0 here in this column, and the left out will be 1. Now one term, 1 is here. So output of min terms is 1. So we will look here. Now what will be, this is 1, so that means x, and this is y, that is 1. So x and y, min terms are always having the product. So we got x, y. This is the same answer which we got with that method. So these are two methods to solve the equation. Sit with the help of, now we will discuss the example of having three variables, right? So here x, y, z, how many terms we have? 1, 2, 3, 4, 5. Again we are having 5 terms. So the possible combinations with three variables are 8. So that means 3 are missing. So we have to find out which 3 are not there in this expression. They are this one, x plus y plus z is not there. See, you can check, x plus y bar plus z bar is here. X plus y bar plus z bar is not here, right? X bar plus yz is also not here. So these are the terms which are not present in that expression. So we will assign it to f bar now, right? We have taken this here. Now we have to take the complement of this, right? So we will take the complement of this. What we will get in this, if we take the complement, x bar into y bar into z bar, this way, right? So product will be converted to sum now, and this sum will be converted to product, and complement x bar into y into z, this one. This will be converted into x into y bar into z bar here, right? So again you can see that these are, we have converted the max terms to min terms now, and this is the, we all are having the sum. This is the sum of products. So that means DNF, right? Now let's discuss it with the help of truth table, right? See, the x, y, z, these are the possible combinations. We will mark all these in this, right? Where these are the max terms. Now we have to see the reverse. See, x plus y plus z means x 0, y 0, z 1. So this is the combination. X should be 0, y and 0. So this is the, this way we will mark all these, right? Max terms have the output 0, these we will put 0 in front of that, and the left out will be 1. See here 1, 1 and 1, right? And we will see here what is the value of x, y, z, 0, 0, 0, that means x bar, y bar, z bar, right? 0, 1, 1, x bar, y, z. Then for this one 1, 0, 0, that means x. So these are the min terms now we got, and this is the required DNF. And you can see that this is having the same answer with the previous method we have solved, we got the same answer. So thank you very much.